Hey everyone, I'm Hendrik. I'm the Director of Special Projects at Jump's Crypto Division. Also used to be CEO of Certus One, which just recently got acquired. And with Certus One, to give you a bit of background, we were founded in late 2018. We were a validator. We're still a validator on the Terra network and a bunch of other networks, and have pretty much been involved since like the early days of proof of stake and since the very early days of the first Columbus network on the Terra side, working together with the folks in launching it and being a validator since then and contributing in various ways. And one of the most recent ways we're getting involved is we're a core contributor to the Wormhole project, which is a cross-chain bridge. And Wormhole V1 was a bridge that was solely connecting the Ethereum and the Solana blockchain and offered asset transfers between the two. And with the Wormhole V2 that we just launched roughly 2 weeks ago, we're not only connecting Solana and Ethereum, but the Wormhole project has started to connect Ethereum, Terra, Binance Smart Chain, and Solana. And we've also made a couple of very, very major changes to the protocol. And in this talk, I want to first give you a brief rundown of how the Wormhole works, what problems it solves, and then we'll dive into how you guys could utilize the Wormhole in your decentralized applications on Terra and beyond. So first of all, I want to dive in and look at what the state of cross-chain communication is. And obviously, especially with Columbus 5, we'll be connecting to IBC, where this is a diagram that I've taken from the IBC page. And we kind of see different hubs being connected and zones being connected with each other, connecting using IBC, where IBC allows cross-chain messaging between these zones. With IBC, we have this hub and spoke model where these have direct connections where this zone and the hub are running light clients on both and verifying each other's blocks and validator sets and signatures and so on. And then if this zone wanted to talk to this zone, it would send its message over that hub to that zone. And that's how kind of trust is established in this ecosystem. This is kind of the state right now. And then if we're trying to connect to chains that don't run on Cosmos SDK or Tendermint consensus or a consensus protocol that is supported in IBC on these particular chains, then we're looking at peg zones, which are special zones that verify the blockchain headers of, for example, the Bitcoin or Ethereum chain that understand proof of work consensus and can at least implement some kind of this probabilistic finality on these particular chains. So the goal of the Wormhole is to allow direct communications between different places, and particularly the places that are, let's say, hard to connect to, where it's hard to build light clients and where extremely fast message transmission without any intermediary hops is important. So in the end, the way we've built the Wormhole and the Wormhole is designed is that the Wormhole protocol V2 design is built in such a way that Wormhole is a off-chain light client network, essentially, where there's validators. So the ecosystem, the protocol has its own validator set, and this validator set observes the chains it's connected to. There's no own consensus or anything running there. We're essentially relying on the individual chains the network is connecting to for finality. The network is governed by 19 guardians that watch these chains, that sign message observations. So what is a message observation? Let me get started with that. So the way the Wormhole works is pretty similar to IBC, but imagine a layer below. We don't have any delivery guarantees. At the core of the Wormhole, what the Wormhole does is it allows smart contracts or users on any of the connected chains to post messages to a canonical Wormhole contract on the given chain. That means, for example, on Columbus 4 right now, we have a smart contract, and your smart contract, for example, could post a message to this Wormhole contract. The Wormhole network, which means these 19 guardians, these 19 validators, would observe this message, and they would produce a signature. And once we have, as typical and usual like BFT consensus environments, if we have 2/3 plus of signatures, we consider a signed message or this message valid. So the Wormhole network has its own peer-to-peer network where these messages are circulated and the signed messages are circulated. And then you can also run a Wormhole node, observe these messages, and store these signed messages. And imagine these signed messages just a little bit like a check. The Wormhole network essentially replaces the line client required between the chains with consensus across these guardians. And with this signed message, you can then prove to any other chain or even an off-chain program that this certain message was posted there. And this also means, since we have optional delivery, there's no like recipient that you specify when sending a message, that this could be like used in a multicast way where you sign or attest some kind of piece of information from your chain. We'll dive into a potential use case later of that, which is then consumed on on multiple other chains. Like for example, you have some way of finding a price on chain. Say you have a pool and you want another chain to get access to the price of that pool. So you could have your AMM pool send a message to the Wormhole saying, hey, look, this is the current price. And then anyone else can use this and verify that actually on this chain at a given time, the price was X. So this is just a high level diagram again. So we have these chains sending messages, the bridge, the guardians observe that, and then you can publish the signed message and use it somewhere. But how does such a message look like? A Wormhole message it has a pretty simple header. And the main idea behind the header is to allow you to do authorization. Why we'll need that, I'll jump into with one of the use cases I'm going to present after. But essentially, we have the sender chain, which is an ID, the ID of the chain this message was sent on. For example, we could have Terra, which is right now 4, if I remember correctly. And the sender address is the smart contract that is, or the user wallet that is sending this message. Then we have a timestamp as a simple sequence number. This can be quite useful, especially the sequence number, because it's like increasing monotonically every time with the one step. And you can guarantee gapless transfers because, like, for example, you have an Oracle price feed. You want to guarantee that every single price feed update is reflected or transferred to another chain. So you can use the sequence to guarantee that it's gapless and no message was left out. We have a confirmation level. That is quite interesting, especially in the Terra use case, because on Terra we have instant finality after one block. So with Terra, this is mostly irrelevant. So we can just wait one block and it's final. But with a chain like Ethereum, this indicates how many blocks the network was waiting before it produced such a signed message. So you can think of it like with exchange deposits. Someone who's posting a message might want to have these signatures produced 5 blocks after, 15 blocks after, just to give stronger guarantees that the message or the action that posted the message isn't going to be rolled back. And the rest is arbitrary data. You can take any kind of binary data and put it in this message. And let's take a look at the first use case that is currently being built to showcase the power of such a simple messaging protocol. And that is how token transfers could be implemented. Let's say we take a token bridge contract on Ethereum, and this has the logic to essentially take tokens, lock them, store them in this multi-sig custody. And then when you've logged these tokens in, you specify who you want to send it to, for example, another chain. And the token bridge will then post the message to the Wormhole contract. And when you post the message to the Wormhole contract, obviously the Wormhole network is going to pick it up. The Wormhole network is going to produce a signature, so another network can easily verify the authenticity of that message. And what can then happen is a user or a relayer in a relayer network can take the Wormhole signed message and can post it to a token bridge on another contract. So what this contract would do is, in a token bridge use case, governance, for example, the Wormhole governance might register the chains with each other. So the token bridge on Solana or on Terra knows the address of the token bridges on the other networks. That is important because otherwise, any smart contract could obviously send messages saying that tokens were locked, so they would be released on that end. But here we use the chain ID and the bridge address to guarantee that a contract we trust or a contract that is part of this particular token transfer network actually sent this message, and then we can trust it. We see 500 USD were transferred in with the intention of, in this case, transferring to Solana to this particular address. So the token bridge contract can take this signed message, and we call these signed messages, once they have sufficient signatures, a VAA. They can take this VAA, they check it with the Wormhole contract. So it's a very simple call that's being made. And once it's valid, they can just pass whichever data was in there and release funds to a user, mint a wrapped asset, do whatever. So we used a simple, just message passing protocol, a simple message attestation to implement a much more complex use case. And the only important thing is that the Wormhole is just essentially responsible for allowing this chain to verify what's happening on this chain. And for example, in this case, building a light client for Solana is extremely complex, given we have blocks around every 400 milliseconds, or slots, how they're called there. It's extremely tough to build a working light client on any other network. So the Wormhole network made it extremely easy and extremely fast to get the signed confirmation and allow Solana to verify ETH state. But on this side, there could have easily been Terra as well. So for example, the Wormhole network is soon going to be rolling out a token bridge, and that is going to use exactly this mechanism. And there, for example, this could be Terra as well. So this was a essentially one-to-one communication example. Another example of utilizing this generic message passing capability would be to transfer Oracle data. So in this example, we're using the Pith Oracle, and this is homed on Solana. And let's say the Pith Oracle publishes prices every 400 milliseconds for, in this case, the Robinhood stock price, some time-weighted average price. And what this contract can do now is it can call to the Wormhole and say, hey, I want to publish the price information. I want a signed confirmation of the price. That means someone else who wants to verify the Pith prices on the Solana blockchain, or blockchain A in this case, they would only need to verify the very simple Wormhole signed message versus having to sync the whole blockchain, or without having to run a very complex light client for the network. So Pith would send a message to the Wormhole containing the symbol that it's publishing the price for, the type of the price, and the price. And then obviously Wormhole message is published. The Wormhole network picks it up, produces signatures once everyone has seen the transaction, and produces the signed message. And now this is quite interesting, because this message, the way the Wormhole is currently implemented by its contributors, is that Wormhole publishes these messages to the peer-to-peer network. The peer-to-peer network is public, so anyone can run a node, anyone can listen to it. So theoretically, someone could be running a node that is just there to pick up Pith Oracle price updates and then publish it to another chain, or use it in some off-chain program. At the same time, the Wormhole currently also stores these messages. So anyone running a Wormhole node, or anyone with access to a public Wormhole node, can use RPC to fetch the signed message and do whatever they want with it. So it's not like it can only be published to a single chain, but any chain that is able to speak Wormhole, essentially, can simply verify this piece of information and use it whichever way possible. For example, there could be a price aggregator that's tracking the price on chain and caching it. There could be a lending protocol that could directly take this price update and trigger liquidation using this as a proof that the price is X. This is kind of what the thing that can be done, and it's extremely, extremely flexible. Really, at the core, there's just this simple message format. You can post and you can verify. So if we think about how you can use this in your application, the flow, we've seen it here a bunch of times, is pretty simple. you find the Wormhole contract on the chain you want to use. So we have one instance deployed on Terra. On my last slide, I have a link collection of the of the Wormhole deployment that's currently adopted by the 19 Guardians that is running on Terra. This contains all the addresses you can use for your cross-program calls. And it also links to the SDK and to a current documentation. So your contract would post any kind of information to this contract. And after one confirmation, so one block on the Terra blockchain, what would happen is that the Wormhole network will start producing a message. This usually takes somewhere between 500 milliseconds to a second. And then you can essentially pull RPC. You can request the signed message from the Wormhole RPC. I think there's in the documentation, there should be, otherwise someone will update it later. There should be one public RPC instance that's currently being run on our testnet deployment. Otherwise, you can run an own Wormhole node. You will be able to access the VAAs that way. And the way you can currently fetch them from RPC is using the tuple of like chain ID, emitter address, and sequence, where when you post a message, there's a log being emitted telling you the sequence of the message that you published. So chain ID, you will know that because you know on which network you sent the transaction. Emitter address, you will know that because most likely it's going to be the smart contract you're interacting with that is posting the message. And then sequence, you will see in the logs. And that way you can fetch the VAA, the signed message, and then you can use it on another chain. So how do we use it? It's pretty simple. Here's again the post message endpoint. Once you call this using your message and a nonce, the nonce can be any random number. You can put anything in there. This is really just for you. If you want to carry a little bit of metadata additionally to your data, you can use it in a nonce. If you want to implement your own custom sequence number or something, you can do that in the nonce. Otherwise, you just put the binary blob of your payload, and that can be Oracle data, that can be an encoded transfer, that can be a governance vote that you want to bridge across chains. It can be any kind of information. You can use that, and then the Wormhole produces the signed message. And if on any of the connected chains you want to verify that VAA, the contracts in Cosmosm, they expose a verify VAA query. On the other chains, on Ethereum, we also have a read-only endpoint on the Wormhole. On Solana, it's slightly more complex. I'd recommend you to take a look at the documentation SDK for how to verify VAAs on Solana. And on BSC, it's the same. You have a simple verify VAA method, and you just take the binary VAA that you retrieved over RPC or picked up on the peer-to-peer network. You submit it and query the contract, and what it's going to do is it's going to verify the signature against the current Guardian set. It's going to do all kinds of checks, verify that the message is authentic, that the message hasn't timed out. There's some timeout mechanism when we change the Guardian set, and so on. It's going to do all the checks, and what it's going to return you is a nicely parsed VAA that you can use to then pick up your message. Let's say you have let's take an example. You are a protocol that's currently live on Ethereum, and you want to move to Terra and build a Cosmosm contract on Columbus 4, Columbus 5, and later. What you can do is you can say, okay, hey, my token's now being bridged over, but I don't want to split my ecosystem. I don't want only one chain to be able to vote on governance decisions. So what you can do is you can have a voting contract on the Terra side or on the Ethereum side. And so you deprecate Ethereum, you move to Columbus 5, Columbus 4 to Terra, and you allow people to bridge the token over. You could potentially use the Wormhole bridge. You can use any other bridge as well. And you say, okay, these tokens on Ethereum that remain on Ethereum, I want them to be able to still vote on governance decisions. So you build a little smart contract in Ethereum that allows votes. And let's say when the vote concludes, it posts a message to the Wormhole saying, hey, look, this is the voting outcome. So many tokens have voted A, so many tokens have voted B. Then the Wormhole network will sign that, will produce a signed message, a VAA. You pick that up, you post that on Terra to a method on your contract. Let's say you have a accept Ethereum vote outcome handler in your Cosm contract. And this takes the VAA. So you post a message to your contract. What your contract will do is it will call the query the Wormhole contract with exactly this method here and the VAA, the raw VAA. And it will return you the parsed information and it will verify it. Otherwise, it will obviously fail and you can handle that gracefully however you want. And once you know, hey, this is a valid message, you will see this. So this is the structure of the parsed VAA. Most of this information is not going to be super relevant to you. Potentially the timestamp if you want to have some kind of timeout or something. But what's important, you will want to check that the emitter chain is indeed the chain your governance contract is on. You will want to check that the emitter address is your authentic governance contract on the Ethereum chain. Otherwise, someone else could forge a message. And in this case, you might want to verify the consistency. Let's say you will only accept if the message has been on Ethereum and has been confirmed for 15 blocks. Oh, actually, I left that out. The Ethereum post message call will let you specify how many blocks you want to wait. We currently allow up to 100 blocks that the Wormhole network supports. This is how the Guardians have currently parameterized their nodes. And you can say, okay, I will accept it if there's at least 15 blocks of confirmation. And then you can go ahead and pass the payload, which would contain your voting outcome. And we also directly give you a hash. So that hash is a unique identifier of that particular VAA. And the way you can use it is you can do replay protection. Like if you don't have replay protection, obviously, someone could publish the VAA multiple times against your node, against your program, and potentially trigger actions multiple times that were only supposed to be happening once. So this is more of a convenience field. We pre-calculate that for you in the program. And yeah, you can then pass the payload. You can store that this VAA has been consumed on your end. And then you can execute whatever you want to. You can track the votes of the Ethereum voters on your chain. And this is just one example of what you can do. There's really no limits. The Wormhole itself is a super, super low level primitive. So we could I thought about even multiple layers of applications being built on top, meaning you could go ahead and you could build a relay network that guarantees people that messages are going to be delivered to another network. So essentially, you produce kind of a proxy contract that will add a little bit of an additional header into the payload of hey, I'm willing to pay 0.3 ETH or something for this to be delivered, which would be a huge fee, but and I want this to be delivered to this particular network into this particular contract. And you would expose the same interface, but with a target, with a recipient, and you would accept fees on the Terra side. And you would allow people to specify an additional payload. So we kind of have nested protocols, just like in the traditional networking, you have very low level IP. And then we've got various protocols layered above. So you could have a UDP, I call this a semi-UDP with no delivery guarantees, but you also specify no targets. So it's if you be really, really, really strict, you could say it's even lower level than IP. But you could implement something that has delivery guarantees, that uses the sequence number to track that all messages have been delivered, and so on and so on. So we think of it, we want the idea of the Wormhole was to produce really the lowest level and lowest layer of abstraction to allow users to really just build things that are extremely useful. And that could be such a token bridge. So with that, I'll quickly show the links. I can drop a link to this presentation in the chat, I think, or have the Terra folks posted somewhere in the Discord for you guys to actually click on the links. But this is kind of the high-level documentation. So we have the contract directory. They will find the current instances of the Wormhole contracts on the various chains. We have a simple SDK, which has some code examples for how from a front end You could like publish the VAAs and actually relay them. We have a client for the RPC endpoint, and so on and so on. Like pretty useful. It's early stage. It's pretty alpha, but we're actively working on improving it. And there have been various contributions. Also, the Wormhole project would be extremely happy about outside contributions to SDK, to documentation, and so on. And if you want to do a really deep dive into the inner workings of the protocol, we have the design docs, which is what like the Wormhole project and like teams and various contributors use to like design new big components of the system. So in these design docs, you'll find a very detailed description of the inner components, about how message publishing works, what the security guarantees are, some comparisons against other protocols, and so on. So you can use that if you want to do really deep dive and become a contributor as well. And that was mostly it from my side. What I'll be doing now is I'll take a brief look at the chat and we'll answer your questions there. So, question for token transfers. The funds get locked in the token bridge. Who has the custody of the token bridge? Is it Wormhole or the project that is requesting the funds to be transferred? With this particular, okay. So, technically, the contract obviously has control over these assets. Practically, the custody is governed by the code of the protocol, as you'd expect, obviously. And the protocol will release these assets if it receives a valid Wormhole message from another chain. So you could say that the assets are held in custody by like the set of all contracts combined. At the same time, obviously, 2/3 plus of the Wormhole guardians govern or control custody, because they are the ones that produce the signatures that are then used to verify and release the assets on the other end. So there's no product, like no project would have authority or control over the custody. It is always just like this contract will only release funds if it receives a valid message from another token bridge. For example, I transfer some wrapped ETH from ETH to Solana, or let's say from ETH to Terra. And then I transfer wrapped ETH from Terra back to Ethereum. Then the Ethereum bridge would release the ETH again, governed by the and controlled or triggered by the signed message. So if you look at the trust guarantees, in the end, you need to trust 2/3, like that 2/3 that the Wormhole guardians are behaving accordingly to the protocol and are not producing fake messages. So currently the Wormhole network is running 19 guardians, most of which are the like highest tier validators in the proof of stake space. We've got a bunch of other players, protocols as well involved there. We have a list of them on GitHub, where there's a registry of all guardians that are currently running the protocol that are currently signers. In the future, we're trying to move beyond 19, but currently, due to some, let's say, computation restrictions on the respective chains, we're going with 19 only and trying to expand as technology will allow. I hope that answered the question on trust guarantees in the protocol. Yes, I'm from Germany. Broad example of user-facing applications this could be used for. Like obviously, the token bridge is one of the most requested use cases, obviously. But I've heard of a lot of demand on the NFT side as well. So token bridge, we're talking CW20, ERC20 type of tokens that can be transferred. And there's a lot of demand for NFTs as well. There's been like someone started work on the NFT design document to build a module that will allow NFT transfers. At the same time, I'm personally extremely excited about being able to allow, let's say, cross-chain governance to happen. I'm very excited about not very user-facing, but in one way or another, it is user facing, being oracles. There's oracles that are only active on some few chains. At the same time, we have AMMs that can serve as extremely reliable price sources that only have liquidity on a certain chain. Let's say we have extremely huge ETH/USDC or Rep BTC pools on Ethereum, and this could be used as a price oracle on other chains. So the Wormhole will now allow this to be used by protocols. For other user-facing use cases, obviously, cross-chain swaps is something that can be built as well. That is highly demanded, and generally anything that connects two chains and requires interaction between them. Like, for example, the token bridge itself, it still requires interaction by the user on two chains. But if a user wants to enter into a new ecosystem for the first time, such cross-chain messages could be used in combination with the relayer network to allow them to fund their wallet for the first time and get started on any network. There's really unlimited use cases in that sense. How an NFT bridge would work. So it would probably work very similarly to a token bridge. At least that's what I'm thinking. But the Wormhole is this is these modules, and I want to stress this a lot. These modules, they don't need to be built by the Wormhole team. There's no Wormhole team. There's a large set of contributors that are pushing code to the protocol, and anyone, even without contributing to the core Wormhole protocol, you can utilize this network. So anyone watching this talk could go ahead and start building an NFT bridge using this and have the same security guarantees as if someone who is currently a core contributor to the Wormhole would be. So with the NFT bridge, how I would imagine it working is you would have a similar layout. So an NFT bridge contract on both chain ends. I'm not extremely familiar with CW721, but I'd expect that it carries the same kind of information and is roughly compatible with ERC721. So when someone wants to transfer an NFT from Ethereum to Terra, what they do is they'd send it to an NFT bridge smart contract. That smart contract would lock it, take it into custody, would post a message to the Wormhole saying, hey, someone has put NFT with address X in there, and it has the following name, symbol, and metadata parameters, where metadata is usually the URL to the metadata JSON. And this would be packed into the message and would be transferred and would be attested by the Wormhole network. Then, and obviously, they'd specify the intended recipient. Then the NFT bridge contract on the Terra side, when it receives such a message, it would parse the information, decode the payload, see, okay, there's an NFT that's called CryptoKitty123. It has the following JSON URL as metadata. And it will mint a new NFT with exactly that name, symbol, and metadata fields and send it to whoever was specified as a recipient. And then you have the essentially ultimate flexibility. When you want to transfer it back, it's burned on the Terra side, or mostly these are implemented as some kind of token with a supply of one, depends on the network. You'd be burning that NFT. You'd be posting the same kind of message back, and you would release the NFT on the Ethereum side again. And the way the current example implementation of the token bridge is built, that you can imagine this is universal. It's 500 USDC, where USDC wouldn't be the literal letters, but the address and the chain ID these USDC originated from. And the cool thing is, if you transfer from Terra to Ethereum, and then from Ethereum to Solana, you get the same wrapped asset as if you were transferring directly from Terra to Solana. So these assets are universally compatible. Cross-chain escrow. I wouldn't be able to think of a reason why it wouldn't be possible to utilize this for cross-chain escrow. the wormhole itself, it just allows you to pass information. So like escrowing assets on one chain and allowing some other chain to essentially release them back when a certain like event is triggered, totally possible. All you need to like take care of is like, which contract do I want to allow to trigger a certain action on which chain, and then you build your trusted network, and you can have governance like make these decisions. So yeah, totally doable. I think there's very few limitations, and if you figure out any limitations, totally open up a an issue on the Wormhole repo. It's github.com/certus1/wormhole. This is where most of the development happens, and which where the V1 of the network was with the yeah. So totally open up an issue there with your use case if there's something that the protocol doesn't govern. The protocol is fully upgradable and is governed by these 19 guardians at the moment. And I think all of them are very, very interested in covering new exciting use cases and adding new features. Bridge aggregators. Um, huh. I think this is a quite interesting question. So the token bridge is independent of the wormhole itself. If I say wormhole, I usually mean the message passing protocol. The token bridge is just like something built on top. With a lot of token bridges launching and a lot of like, let's say, competing ecosystems, we will have fragmented liquidity across different wrapped assets. I eventually expect there to be more of a winner unless there's protocols that cover use cases that, for example, a wormhole can't cover. Like, for example, a REN BTC, a decentralized wrap BTC. This is nothing the wormhole can do unless we get full smart contract capability to verify these signed messages on BTC. So with these, I expect a lot of like synergies to exist. But with other bridges, I expect for the midterm at least there need to be some kind of aggregation, at least on the liquidity layer, where there need to be swap pools between the different kind of wrapped assets. With bridges itself, I mean, you probably wouldn't need to use multiple bridges at the same time. Let me check the chat. Maybe I missed an earlier message. No. No, but generally, I hope that the generic mechanism, the way this was designed, will allow to cover most like and a lot of new exciting use cases that maybe like some of the contributors and designers of protocol haven't thought about. I think this is like the lowest common denominator I could think of at this point. What's the general background, my general background building in the space, and what recommendations do I have for new builders in Space Camp? My background is my background's mostly in cybersecurity. So prior to getting into into blockchain in general, I was mostly doing security research, and in the blockchain space mostly. Certus One has always been focused on building technologies that allow networks to scale and make them more secure. So from a validator perspective, we've contributed with a lot of tooling, always been on a very, very low level, working on the protocols itself, contributing to the protocols. And then last year with the Wormhole V1, we like bootstrapped this decentralized protocol because as Certus One, we were involved in a lot of protocols and found it extremely sad that like there were a lot of very thriving and active ecosystems, but they were isolated from each other. And this is how we kind of got into this, and the responses of people using it and wanting to use it for more than just token transfers with the V1 has really been like almost overwhelming, and I'm quite happy to be working this. So for new builders in Space Camp, I mean, DeFi is an extremely exciting space. I think the intersection of like NFTs and DeFi is extremely exciting, and in particular on Terra with the stable coins and resident protocols like Anchor. There's a lot of like exciting use cases that can be enabled using that and utilize these different protocols in there. And hopefully with the wormhole, they'll be able to utilize assets from other chains to be build exciting stuff like lending based like collateralized with NFTs and directly using the NFTs to maybe deposit into to Anchor in some way or do fun stuff. I think the most exciting use cases really often lie in using the interoperability that these chains gives us in the ecosystem, like even within Terra, to build new exciting things as a combination of the singular pieces that are given. And I think there's an infinite amount of things that can be done. And I hope that with the wormhole, there's an even larger amount of things that can be done utilizing both assets and information from other chains to build cool things. Cool. And yeah, I think, yeah, that's basically it from my end. If there is no last minute questions coming in, I'd say thank you to everyone listening. If there's questions about the wormhole in general, the wormhole has the wormhole network has a Discord where there's a dev chat and a lot of contributors are there. You'll find the guardians there to answer your questions or for you to become a contributor. That would be extremely amazing. I'll try to send the links some way where you'll hopefully find them so you can start hopefully integrating with the wormhole and building new exciting stuff. Looking forward to it. And thanks, everyone. Have a nice rest of the day.